Okay, so I decided to end the last video early because I realized I was going to go over time for YouTube, and so I just wanted to start this fresh before we start with number 9. So I went ahead and wrote down the equation being used in this story problem, but let's go ahead and read it. So it says, the deer population in a forest from 2000 to 2010 can be modeled by y equals negative, well, this whole thing, where y is hundreds of deer. Okay, so that's important. Y is hundreds of deer. Okay, that's an important detail. And x is the numbers of years since 2010. So x is going to be equal to, or not 2010. X is basically going to be equal to, like, whatever year it is. So this is like the current year minus 2000, right? So whatever the current year is, so if it's 2006, we're going to subtract 2000, that's going to be 6. So x is going to be equal to 6 for that type of problem. Okay. When was the deer population 500? Okay, so the deer population being 500 actually means that our y value, we already know what it is. If this is hundreds of deer, then the y value we want is 5, because 5 is going to equate to 500 deer, okay? So I'm going to replace the y with 5, and I have the rest still here. Okay? Now, if I'm going to solve this using the quadratic formula, I need to first set it equal to 0. So let's move the 5. Oh, I don't know why I just wrote that. I wrote minus 0. I was getting ahead of myself. So 0 equals negative 0.1 x squared plus 1.1 x minus 2. Okay. Now from here we can use the quadratic formula. In fact, this is kind of an example of why you would only want to use the quadratic formula for this. Imagine trying to complete the square or factor this. That would be impossible. And don't even get started with graphing. Like, graphing would be impossible for this type of a problem. So let's go ahead and use the quadratic formula. X equals b squared, so 1.1 squared, plus or minus, oh, sorry. I got that mixed up. I'm going to start over right here. X equals negative b. Okay, so negative b is negative 1.1 plus or minus square root of 1.1 squared minus 4. A is negative 0.1. C is negative 2. All over 2a. Okay? All right, this looks crazy at first because it's got a lot of decimals, but trust me, you can solve this, especially with your calculator. So let's go ahead and solve each of these. So we got the exponent here that we're going to solve, and in the same breath, I'm going to solve each of these, okay? So I'm going to do x equals negative 1.1 plus or minus square root of 1.1 squared. I actually know what that is off the top of my head. I believe that's 1.21. And that's just because I know what 11 squared is 121, and I know that this is going to have 2 decimals, so it's 1.21. Okay? 4 times 0.1 is 0.4, times 2 is actually 0.8. Okay, so I know there's going to be 0.8, so I'll go ahead and write that, 0.8. Now I got to determine what's going to go between these, plus or minus. So negative times a negative makes a positive, times a negative makes a negative. Okay. Another way you can tell is how many negatives you have. 1, 2, 3. Well, if you have an odd number of negatives, then it's going to be negative. If you have an even number, it's going to be positive. So in this case, it's negative. Okay. And then all over 2 times negative 0.1 gives me negative 0.2. Okay. I'm going going to solve this on the inside here. I get negative 1.1 plus or minus the square root of. Now if I solve this, I believe this might be where I have to take the calculator out just to make sure I don't make a mistake. I think I could solve this in my head, but when it comes to decimals, sometimes I get a little confused. So this gives me 0.41. Okay, negative 0.2. All right, now from here I gotta keep going. I can't actually solve what the square root of 0.41 is, but I do know one thing. I do know that when I solve this, in fact, let me go ahead and type this into my calculator and see kind of what the answer would be. So it's going to be above, yeah, so it's going to be 0.64. Okay. So we might have to make this one kind of an about statement is what I'm thinking. So let's approximate the answer. So if we're using all values that are just one decimal deep, like we don't have any that go past 1, let's go ahead and round our answer. I guess this was technically 2, so maybe we can do 2. So let's do negative 1.1 plus or minus 0.64. Okay, and I kind of like that because there's a 0 behind there, so it's actually really close to this number over negative 0.2. Okay, so this is where I got to do the split. So first I get 1.1 plus 0.64 all over negative 0.2. Or sorry, negative 1.1. Okay. If I end up getting a negative answer, which I won't, I think I get a positive answer here. So we probably don't have to worry about that. I'm going to clear my calculator. I'm going to do 1.1, oops, negative 1.1 plus 0.64 equals negative 0.46 divided by negative 0.2 gives me 2.3. That's a pretty good answer. So 2.3 is one of my answers. Now let's get the other answer. So I got negative 1.1. I still have to do the minus side of things. Okay. Now let's solve this. So negative 1.1 minus 0.64 equals that, divided by negative 0.2 gives me 8.7. Okay, so there's my two answers. 8.7. Okay, so when I'm answering this, the question was, when was the deer population about 500? So it says about, so that's actually an indicator that we really do need to approximate this. The fact that the question even says the word about. So we would say about 2.3 and 8.7 years after 2000, or after, maybe say after the year 2000. Or in other words, we could just say in the years. So if this is 2.3 years after, that'd be the years 2002 and 2008, which means we didn't really even need the decimals if we wanted to answer it this way, because if you're only 8.7 years into a year, you're still in that year, right? Like we're in the month of May, so we're like 2 5/12, or we're 5/12 of the way through the year, right? Okay, so let's go ahead and do B. Trying to make sure this doesn't become too long of a video. Do you think that, oh, maybe not. Maybe it'll be pretty short. Do you think this model can be used for future years? Explain your reasoning. So do we think that this model can be used for future years? To be honest, I would say no, because once again, we had to get approximations out of this. So I don't think it's very accurate. So I would say no, because we had to use approximations in our answers, or in our answer. So it's probably not a very accurate formula, to be honest. Okay, so that's how I would solve number 9. Yeah, if you need help with any of the other ones, just make sure that you come and see me or talk to me privately through Google Classroom so we can resolve the issue. Thanks.